Welcome to the panel discussion on virtual robotics. I'm Karen Young, CEO of WOZ ED, and I'm thrilled to be here with Dan Mantz, Vikas Gupta, and Keith Oelrich to talk about our own experiences with virtual robotics and physical robotics and the advantages and benefits of that. I'm going to have each one of our distinguished panelists introduce themselves and tell you a little bit about them and why they're here. We'll start with Dan.
Hi, my name is Dan Mance. I'm CEO of the Robotics Education and Competition Foundation in Dallas, Texas. We actually have robotics and education programs for over 1 million students in over 70 countries. When we started over 10 years ago, most of the emphasis was on physical robotics. But as robotics has evolved, and especially with the impact of the pandemic last year, we've seen a huge growth in virtual robotics, and it's really changed how we run our programs. My background is actually in industrial robotics. I spent over 20 years at Fanuc Robotics, and like educational programs, the industrial robots have also evolved from being very mechanical and electrical to really integrating virtual simulations and programming. So I think this is a great topic and really relevant to both education and to traditional workforce development.
That's fabulous. I'm sure there are going to be some great insights from that experience. Vikas, let's go to you.
Hi, I'm Vikas Gupta, founder and CEO of Wonder Workshop. We founded Wonder Workshop in 2012 with the goal to bring coding and robotics to young kids everywhere. So we work with more than millions of kids across thousands of schools. In the US, we work with teachers across more than 25,000 schools, primarily elementary schools, so kindergarten to 5th grade and some in middle schools. And our robots, Dash and Dot, have been leading the pack in terms of STEM and coding and education in robotics for the past decade. And over the last 2 years, we've seen how, especially with the impact of the pandemic, as Dan mentioned, the need for access to the same elements of education, but at times being remote. And what we've also seen the benefit with virtual robotics is being able to make it a lot more accessible and affordable as a result. There's obviously no replacement for physical robot, but virtual robotics, I would say, is the closest it comes to making that accessible to a large population.
Fabulous. And Keith.
So thanks for having me, everybody. I'm Keith Oelrich. I'm the CEO at Learning.com. Learning.com is, our purpose is helping to prepare students for success in the digital world. We have a digital skills curriculum and platform that we sell to schools, districts, and states in some cases, mostly around the US. We're in about 10,000 buildings across the country. We're in about 10% of the districts in the country. And our digital skills curriculum covers everything from computer fundamentals and keyboarding for the youngest students, online safety, digital citizenship, information literacy, all which are very important topics, business applications like spreadsheets and presentations and word processing. And then we've, in the last couple of years, extended into coding and computational thinking. And a big part of our mission is tackling the digital divide, addressing digital equity issues, which have become much more important through the pandemic. And we think virtual robotics is a great way to get at attacking that. So I'm excited to be here. Thanks for having me.
Oh, that's wonderful. Such great perspectives. And I think, that gives us an idea of the backgrounds of the people that have come together for this panel. But I think all of us also have some personal reasons for being so passionate about this work. And Vikas, I'd like to start with you to talk about the origins of Wonder Workshop and the personal aspect of that for you and how much these kinds of things when kids are engaged create really profound and powerful learning.
Sure. So my background is in computer science. I grew up as learning computer science in my undergrad and master's. I got access to a first computer. I grew up in India in a small town, and our school got access to 2 computers, PCs, in the mid-80s. And our school principal saw my interest in computers and gave me access to the room, essentially gave me the key to the room so I could go in and use it anytime. And that's had a profound impact on my life. And I've worked at companies like Amazon and Google. And then in 2011, when my daughter was born, and I saw her, taking to these devices and thinking about how children growing up in the 21st century will have access to very powerful devices in their hands at all times. These devices can be used to consume or can be used to create. And I think as parents, as educators, as innovators, the onus lies on us on what direction we take that forward in, and what tools can we give our kids so they can truly use these tools to create and go behind the scenes. So that was the impetus and the motivation and the inspiration for us to start Wonder Workshop, learning from our own kids, understanding that we as creators of these technologies also have the responsibility to use these, help these children use these technologies to be the innovators in the 21st century. And I would say we take a lot of pride in things like, the platforms we build are used by boys and girls equally well. We work with more than millions of kids across thousands of school districts, and every year they come together to participate in our annual robotics competition. And the kind of creative output we see from these kids has been inspiring all over again. So we continue to do this because these kids inspire us to do what we do.
And what you said is so important too. We need, as educators, to help students become producers of things, not just consumers of technology. That's where the power is. And it was really, really good to hear that in your statement. Thank you, Vikas. And Dan, Vikas also mentioned competition. Do you want to talk to us about virtual and in-person competitions and what your experience have been with robotics?
Absolutely. So the REC Foundation has been hosting VEX robotics competitions for over a decade. And we believe that that physical robotics competition gives students hands-on opportunities to especially learn the engineering design process. That's something that's really, really important to me. And 15 years ago, the focus was on building and designing, but just like in industrial robotics, more and more sensors, more and more technology have necessitated an increase in computer skills. And we believe that, virtual robotics is the evolution of traditional robotics. And we don't think it replaces traditional competitions or hands-on building, but we do believe it's an important part of it. In particular, as students learn computer programming, it becomes a skill just like reading and writing used to be. It's going to be so important to future workforce development. We can now use the physical robots to reinforce your design skills and your build skills, but now you're learning the programming to really optimize the performance of the robot. And we feel that competitions still have a place. For us, it's not about winning or losing. It's about developing the soft skills that come with learning the technology. So at competitions really forces students to learn how to communicate with their own teammates, learn how to troubleshoot, how to problem solve, and really these soft skills that they're learning from hands-on competitions, from virtual robotics, are the soft skills are what we're really, really developing in these students. And that's going to be beneficial to them no matter what careers they pursue.
Absolutely. When we think about if they do pursue a career in tech workers are always in beta. So it's not necessarily the skills that they're getting or the language, it's their ability to think like an engineer and to learn that's going to be most important to them if they go on that path. And I think it's probably one of the most important things that we do. It's an area too where sometimes teachers are afraid of some of this because maybe it wasn't part of our own background. And so Keith, I'd like to hear how you approach code learning at learning.com.
Yeah, we actually think of coding instruction as a continuum. And if you look at the CSTA standards, the Computer Science Teachers Association standards, which are de facto national standards, state standards are being developed. They usually start with CSTA and amend them somewhat. But if you look at those standards in the earliest grades, a lot of what the standards require are the foundational digital skills that Learning.com has been teaching for a long time. So we start in the earliest grades with teaching kids the digital skills that they need, and then extend up as kids get a little older and a little older. You can see them starting to extend into coding and into now virtual robotics.
Oh, that's wonderful. And Vikas, how do you think the ability to do the simulations and to give this kind of access where it's not just a shared resource in the classroom, but every kid has access to their own robot and their own simulated environment, how do you think that changes the scope of learning? I know from WOZ's standpoint, his inspiration to us is always get kids doing something they really like, because then you've got a lifelong learner. He'll talk about the books that he went and found and the manuals that he obtained because he was so interested in building computers. And so when we can connect children to that love, they find opportunities to continue to learn on their own. So Vika, speak about how you think the simulation and these kind of capabilities of one-to-one through virtual robots can impact learning.
Yeah. I think you made a very important point, which is that if you can get kids hooked onto something that they really enjoy, then you have a lifelong learner, because then you create this intrinsic motivation for why kids are doing what they're doing, and they'll challenge themselves and they'll go, lots of places. So we've seen that, time and time again, where, as we created these robots in a platform that is highly, highly engaging, kids take to it and they'll challenge themselves and they'll go places. But I think the one challenge that we've seen that has been, how do you get robots in the hands of every child? No matter how affordable you make the robots, at the end of the day, whether you work with schools or you work with parents, not every parent, not every school can afford the same sort of amount of equipment for all the students. So how do you create a platform that is accessible to every single student? And that's where we've seen the impact of virtual robotics being the most, which is we can work with a school full of 400 students, and now they don't need 400 robots or even 100 robots. They can actually have robots complement virtual robots in a way that every student has access to a virtual robot. And the way we've done is we've integrated all of our curriculum, all of our coding applications, everything the student does with a physical robot is replicated in a virtual environment. So then it opens up another avenue, which is for a child to really iterate and test and debug. A virtual robot can be very productive because they can actually go iterate on that very quickly. And the magic lies when they take that same program and then run it on a physical robot and see that all come to life. That reward is just, is astronomically huge for a child. And that's, I think, where we see this complementary aspect of virtual and physical robots, that it allows students to iterate, debug, go places, learn at their own pace, and then at some point bring it to life with physical robots, or they start the other way and go the other way as well. And then it enables every student to come online. It makes it possible for schools to be able to afford to implement this at a much larger scale, so we can actually get to one-to-one access to robotics. And that's, I think, what we've seen the really big impact from the virtual robots, as well as complementing it with physical robots.
As you were speaking, it made me think about the way we train our airline pilots.
Yeah,
we don't start them out in a passenger plane. We start them out in a simulator and give them the chance to make those mistakes and learn in a very safe environment before they are taking any of those risks. And perhaps the future of this with coding and robotics is very similar.
Yes.
Karen, I would just, Karen, if you don't mind, I would just add on to that point. We're just in our first selling season working with Robotify and taking virtual robotics into our customers. But the biggest bulk of all of our initial orders have all been full building orders. So just as the point that Vikas was making a moment ago, you weren't going to see buildings ordering robots, physical robots for every kid in the school, but we are seeing the vast majority of our early orders are for districts or schools buying access to virtual robotics for every kid in the school. And we don't know exactly how they'll implement that and how they'll get it in front of each kid. It's early stages for these customers, but the promise of putting robotics in the hands of every student certainly seems to be being fulfilled.
Well, and that's exciting too, because even after hours, if they are really into it, I'm sure they can log in and continue to do their work within that platform, which extends that access. It's exciting to know that that's a possibility. It doesn't have to end at the end of the school day if it's something that the kid's really into. So I know in our own partnership and relationship with Robotify too, we're taking this into other STEM areas as one of the developers, into cybersecurity, artificial intelligence, digital animation. So we can expand those simulations much for the same reasons, Keith, that you're doing that. But even with just virtual robotics and coding, Dan, have you seen that move into other subject areas? Have you seen an impact, for example, in math or reading or science or that kind of interest?
Absolutely. I think that's the beauty of robotics. I think that we want all students to experience robotics virtually or physically, right? But we also have to understand that not all students will this will be their passion and that's what they'll continue to do, but to have to understand that base. But what it does is I think it ties the math and the science together. So students that are taking these classes, they may not understand the actual application, but whether you're doing a simulation or whether you're physically building a robot, because I personally feel the hands-on is still important. As Mr. Gupta said, is you need to program and simulate and then download it and see that it works. But that said, whether you're doing it virtually or physically, understanding gear ratios, understanding velocity, these are real things that you see in robotics, whether you're doing the Robotify platform, the Vex VR platform, all these platforms, you're seeing the actual application of math and sciences, and that makes it real versus just learning in a classroom. And I think that's where we're really, really evolving in STEM education and computer sciences, as providing a direct impact that the students aren't bored with math, they are not bored with science, they see how it really works in the real world.
I think that is so spot on, because I've seen students that get so frustrated when they are handed a worksheet of 50 math problems, because it's mind numbing and they have to wait until they're done to get any feedback. I've seen those same students working with CAD/CAM programs to do something with a 3D printer that they just won't stop. And the thinking is at so much more of a complex level. So I can't help but think I would love to see some studies done that show the impact of this kind of learning and what all of us are focused on a student's resilience, on their persistence, and how much that has to do with their performance in other content areas. I think it's just so core. So Vikas, do you want to speak to some of the things that you have seen in terms of how access to a virtual robot, with what you were talking about, has an impact on a student's learning environment or their process versus what you experienced with physical?
Yeah, I think I also want to touch upon something that Dan mentioned, which is kind of this, impact in other subject areas, both with virtual and physical robots. And an example is also to maybe highlight the difference between a virtual robot and a physical robot. So, and that example would be when you put a robot on a physical surface, how it responds to the physical surface and how it moves, is very different how a robot will move in a virtual environment. And I think that's a moment of, that's a learning moment for a child, because why doesn't the robot move exactly 10 meters in a physical space when I programmed it to move 10 meters, when in a virtual environment, it moves exactly 10 meters, right? So that difference gets highlighted a lot more, because it's not because I coded something wrong, it's the physical environment that's making a difference from what a virtual environment does. And that's where, for a curious child, it's a moment where why is it different, and leading to a whole pathway of understanding aspects of science, which involves math and which involves everything else. But that's a really, really interesting aspect to highlight. And I think this is one thing that I wouldn't say that we've seen a lot of output yet, but we see this potential where when you put physical robots in the hands of children, there can be a lot of frustration around, okay, I programmed the robot to make a square, but it stopped short of, it's 2 millimeters short in the end, because there is a certain amount of error that builds up over a period of time. In a virtual environment, it'll do exactly the physical, that one, square. There won't be any error at all. But when you're doing only with physical robot and not with the virtual robot, that moment of learning is in some ways lost, because kids are always questioning themselves, because maybe they did something wrong. But when you combine this with a virtual environment, and they know that what they did is actually right, theoretically, the gap in implementation leads to a whole aspect of curiosity around, what's different about a physical environment. And to me, that's a really interesting aspect to bring out for children, because I think this leads to an aspect of learning about the physical aspects of robotics. A lot of things that often kids will either take for granted or ignore, or it gets lost in instruction, because there is no comparison of a perfect environment and a less than perfect environment. And that's, I think, I would say, the potential for impact, specifically for a virtual robotic. Like, you can do a lot of virtual environments, you can do VR, but there is no, in virtual robotics, there is a virtual environment that has a physical complement to it. And having those two both being available to students and teachers, I think, can be far more impactful, because you can see the difference much more realistically than you can in other environments. And I think that's something we see the potential for going forward, in that complementing these two can be a great way for kids and students.
Well, and what you just described is a really powerful engineering principle. Why did it not work the same way? And to really dig in and figure out why is that different. And it's almost like what's so important in our science curriculums right now is for students to study a phenomenon, which you could put that into that phenomenon category of why is it different? And the learning that comes as a result of that is very, very powerful. Dan, I want to have you speak too on the importance of this work in terms of workforce development. I recently saw a statistic that within 13 years, 27% of jobs will be replaced by robots, which says to me that all of our children need to at least be able to work alongside them, if not use them, code them, design them, right? That it's going to become a really powerful part of what that means. A kindergarten student today will potentially enter a workforce, even if it's an entry-level job out of high school, where 27% of their colleagues or the interaction that they have is a robot. So can you speak to that?
Yes, absolutely. It's interesting. In my 5 years in a nonprofit and doing robotics competitions, and my 20 years at FANUC, the question I'm asked the most is robots going to take our job? And so many people like to hand wave that answer. But the fact is, yes, there are robots that are going to take jobs. But the fact is the data is showing they create other jobs, and the jobs that they're creating are going to be very STEM heavy. And I think our workforce has to evolve. And I think that's why virtual robotics is part of the solution. It's not the whole solution, but it's part of the solution because, as I said earlier, students are expected to learn to read and write in education, right? And I think understanding coding, that doesn't mean that you have to become a world-class programmer, but understanding coding is going to be essential to get good paying jobs in the future. And I think that's where robotics really, really works. So whether you pursue a career or hobby, when you build a robot, first of all, as you all said, when you get virtual coding opportunities through Robotify, through Vex, through Wonderworks, everything, when you get this to these students, all the students get an opportunity. And then you have a chance to take what you've learned, apply it, and you have that understanding. So when jobs open up, you can speak that language, you understand that terminology. And Karen, you mentioned earlier, are we seeing results? I think the pandemic, as unfortunate as it was, I know in our organization, we had to pivot to a lot more remote competitions, a lot more remote learning. And, we provided through our partner Vex, we provided Vex Code VR, and over 2 million students and teachers have learned coding. They've developed over 3.5 million Python and blocks programming. And what I saw in the real world is when we did resume in-person competitions earlier this year, the programming part of our competition was better than it ever been. So we start all our competitions with an autonomous period. It's fundamental to what we do. And, we were always excited when all the robots could move and maybe 50% of the robots could do one of the tasks. But coming out of the pandemic, because of virtual robotics platforms and the coding that we emphasize, a higher percentage of students were coding better and performing better than we've ever seen. So we know that virtual robotics works. We know that emphasizing programming platforms do teach those students the skills that they're going to need.
That's wonderful. That's a great statistic. And I'd always love to hear the benefits of the good things that have come out of the last year and a half. And that's certainly one of the good things. Another thing that we talk about a lot, and we're really fascinated with, is the importance of the integration of different areas of STEM. And of course, coding and robotics is at the center of it. But for example, if you think about animation now, Disney has animators build one frame, and then artificial intelligence fills in the gap so they don't have to build frame by frame by frame to get full motion video anymore, which says to me that a digital animator needs to know something about AI, right? If you think about SpaceX and the historic trip to the International Space Station, it took a lot of engineering to build those rockets. It took millions upon billions of lines of code to get everything to operate, data analysis to make sure it was operating correctly, artificial intelligence to interpret that vast amount of data in a way that the human brain could absorb it, and robotics to link it to the International Space Station once it got there. So Keith, if you could speak to just how things have changed from someone entering the workforce and having a job where they did something very specific to being on more of these agile teams that need to understand. It's like I'm strongly of the belief that every child needs to learn at least one coding language because of the importance even of being able to communicate with other team members and know the fundamentals of that area. So could you speak to that?
Yeah. Yes. So we're a digital animation company, and so we have animators that do exactly what you said. You know, we're building a frame and then using artificial intelligence to fill out the rest of the animation. And with their great tools that our animators have to use, and so yes, that impacts that particular workforce area. You know, so yes, you know, if you think about when we started getting into coding, one of the things that was interesting is that you know, schools have been teaching coding for decades, right? Schools have been teaching coding for decades, but it used to be that coding was in, or computer science was taught in high school, and it was taught to the geeks, right? And now what's changed in the last, it's been, you know, maybe 4, 5, 6 years now, is you start to see districts all around the country saying, we're going to provide coding and computer science instruction to every kid in every school, in every grade level, right? And all of this really started to happen, I'd say around 2016. You started to see districts like New York and San Francisco and Chicago that all said, we're going to provide this coding instruction to every kid in every school without knowing how they were going to do it. And so now you're starting to see the importance of just this recognition among traditional educators that this set of skills that you learn through exposure to coding is something important for kids that will take that will make a difference in whatever career they're going to be in.
Absolutely. Fundamental. And Vikas, do you have any thoughts along those same lines as far as the benefit and how much impact there should be, how much penetration there should be in our school, how much time we should spend in these areas?
I think, as Keith mentioned, the coding in the end isn't necessarily, it's going to be a fundamental skill that every student, every child, everyone growing up in the 21st century will see an impact of in their lives. And I think and in many ways, many of the professions are going to be impacted. So we're only seeing, I would say, just the tip of the iceberg at the moment, even today. I think that the pace of evolution of these technology is faster than any technology related to software development, is faster than any pace of any other technology in the history of mankind. I mean, if iPhones did not exist until 2007. And we have 14 years later, and we have smart devices in the hands of every person around the world, right? The kind of amount of data being collected, amount of artificial intelligence being employed to it, the fact that we can understand voice, we can create frames between animations. All of these are technologies that have come to existence only in the last 1 decade, right? Only in the last 10 years. And you can imagine the pace then, if you articulate or draw that arc over the next 20, 30 years, where that pace will go, we can't even predict what the world will look like in 20 years from now. So what we need to do, and I believe the impact on every child growing up in this 10th century is going to be that coding is going to become a fundamental skill in no matter what profession they have. You mentioned an animator is an artist, will have an impact and will have aspects of coding and AI or other tools that they'll actually use. A lot of tools that were on pen and paper are all moving to digital, have already moved to digital probably in all aspects of our lives. If you're a journalist, like I remember reading about a journalist in LA who had written code to write an article as soon as it detected seismic activity. And he was the first one to publish an article online in LA Times because his code had woke him up at 3 o'clock, had written the article for him. All he had to do was read it and press a button and the article was live literally seconds after the earthquake happened. Now imagine the difference in how many different professions that coding is going to have. So as educators, I think the only thing we can do really is to give those tools to our kids at a young age, have them grow up learning with these tools. So they're ready for no matter what the change is in 20 years from now, because we can't predict the change, but we can help them take charge of the world they'll be in, no matter what the change is.
I think that is so true. And it seems to me that we're getting to a point with this, that it's more accessible, more democratic with more options. And what I mean by that is It used to be, and Dan, I saw you smile, so I'm going to throw this one to you. But I saw you smile when you mentioned, and it used to be just the geeks that went into computer science, right? But now you've talked so much about these virtual environments and the richness, virtual reality. I just got an Oculus 2 headset yesterday. I was blown away by it. Digital animation, which you spoke to, Keith. It's like a drone is a robot that flies, right? So, and there's so many careers around that industry that are coming that aren't just about the people that master Python, but there are opportunities for the child who is a fabulous artist now in the tech industry. It's just the opportunity has widened. So it's not just those that are fabulous at math, not just those that are fabulous at coding, but it just is all embracing. It's not just those who have mastery of the English language. I've been stunned by how powerful this has been for our English language learners who are still trying to catch up in reading, but they can whiz. You don't have to know English to learn Python. So it's just, to me, it's such a table leveler. So Dan, do you want to speak to the expansion beyond the Geek Club a bit?
Yeah, I think so. It's interesting because I'll date myself here, but I was a senior in high school when our school got TRS 80s, the old Radio Shack TRS 80s, and they wouldn't let
trash 80s.
Yeah, the trash 80s, and they wouldn't let us do it because we were seniors and we were too far behind the curve. So it was only for the sophomores got to use it. But yeah, it was the tech, the geeky people. I mean, I started my career in robotics and I was a controls engineer, i.e. I did a lot of programming at the beginning of my career. But it's amazing. You know, I have 4 children and 2 of them are more into the arts side of it. But they're still applying technology. Photography is a good example. It used to be you had to have lighting perfect, and now you have all these filters and programs that are AI based that do the editing for you, and people can create master art pieces based on a poor quality photography print, which I don't recommend. Learn the lighting, but still it's evolved in everything. And again, it's as we've all touched on, it's not just the future engineers and STEM professionals. It's going to be the people that dabble with it and understand it, but they're going to apply this technology to whatever career path they go. And I think it's revolutionizing. I sometimes wax poetically, but people say, how are robotics going to change the world? And I think hopefully they change it for the good, that we have more time available, more free time, and that actually leads to the next renaissance, right? Because the dull and the dangerous work is now being done through AI and through robotics, and that frees us up to use our creative sides and really, embrace arts and embrace science, embrace performance arts and stuff like that. So I do think that just like we all take English starting in first grade, through our programs, our VEX 1, 2, 3, VEX Go programs, we're introducing computer programming at the very earliest ages. And I think that it becomes a K through 12, K through university continuum, that it becomes like reading and writing. And so that we are free to do other endeavors, and hopefully that improves our work, our lives.
You bet. And the implications, I'm thinking about convenience too. I'd like to get my Amazon package delivered by drone in an hour or less personally, but we're about to the end of our time, and you have just been given some fabulous and fascinating insights and given me a lot to think about. I'd like to go around to everyone and just have you share with our viewers a takeaway or a last thought that you want to leave them with. Keith, would you like to start?
Sure. So I've been working in online education in the K-12 space for 20 years. I've been a CEO for 20 years in the space now. And ever since, all the way back to the beginning, when I was at Apex Learning, the problems that we're tackling are largely about access. Online learning it solves it addresses a number of different problems, but one of the biggest ones has always been about access. And so we see this growth of interest in virtual robotics as just another step in that direction of trying to bring really important skills education, soft skills, and problem solving, and all the other things that you get out of robotics, and bring it to everybody. So we're excited to participate in that.
That's terrific. Thank you, Keith. Vikas?
So I think over the last 10 years, we've seen the growth and adoption of computer science in schools all over the world. And I think what's exciting for us to see is this ability to create one-to-one access for students across the entire school districts, and not be limited in some ways by how much budget can a school create for implementing robotics. I think being able to do that is I think we see as a great opportunity now, given where we are, and also creating these moments of learning, as we talked about, contrasting between what can be done in a virtual world versus what can be done in a physical hands-on environment. So I think both are critical aspects, and then schools can now implement them with affordably for all the students.
I agree with you completely. Dan.
I would also agree that the evolution of virtual robotics has really made this technology more affordable and accessible to more and more people, which is really, really important. And I view this as one piece of the overall development process, right? So this is a important part, but a supplemental part of hands-on learning, of imagination and creativity. But most important, it gives us a platform to fail, to make mistakes, to make corrections without actually doing any damage, and to persevere. So I think this is a very powerful tool, and organizations like Robotify are doing a great service to students everywhere by providing these platforms.
That's terrific. And as I listen to you all talk about the power of the work that we've all done and the potential of the virtual environments and the virtual robots, it made me think of this as my last comment to our viewers that have been here with us, is that if we can make this accessible for every child and give them the opportunity to go as deep as they can go, imagine what they can learn. And perhaps one of them will create something on their own that changes the world, just like Steve did. So I want to thank all of you for being here. It's just been a joy to interact with you this way and to hear your insights. I've certainly had a lot of things that are going to continue to be things that I think about as a result of this. And thanks to you for being with us as our viewers. Enjoy the rest of the conference.